Welcome back to the study of sequences. We are going to talk today about subsequences. You are familiar with the idea of subsets, so you could be familiar with the idea of subsequence also, or you can make it up in your mind. It is very good to make up concepts in your own mind. So suppose you take a sequence x1, x2, x3, x4, x5, x6. I hope I am maintaining 1, 2, 3, 4, 5, 6 correctly, and then suppose I want to just construct a new sequence out of this sequence. So what I would do, say for example I choose x2, then I choose x3, so I leave out x1, I drop x4, then I choose x5, x6, I drop x7 and I choose x8, x9, drop x10, choose x11, x12 and so on and so forth. So drop the first, take the next two, drop the next, take the next two and so on. So what I have created is a subsequence which is consisting of x2, x3, x5, x6, x8, x9, x11, x12, x14, x15 and so on. But remember that here I have to maintain the order of the indexes 2, 3, 5, 6 and so on. The increasing order of index has to be maintained. If I say first put x6 and then I put x2 and then I put x12, it is not a subsequence, and this is a very important point. If you do not maintain this point, then you can't play with the subsequence. So playing with the subsequence is a very, very important game that mathematicians play, and that has to be kept in mind. Now you might ask me, what good is subsequence or sequence or any of these is in your studies in engineering, because you have to differentiate, you have to integrate and do all those stuffs. The real issue is the following: without having a good understanding of sequences, you might not be able to have a very good understanding of even differentiation and integration, continuity or whatsoever. Sequences is some sort of a discrete version of the analysis that or calculus that you are learning, but okay. So it might not look very useful at the very moment, but it has some use as we go on. So here is the famous Bolzano-Weierstrass theorem, which says every bounded sequence has a convergent subsequence. So let me take a sequence which is bounded -1 + 1 -1 + 1. Now you are already accustomed with the sequence, pretty cute sequence, and of course it is bounded by 1. And now I take a subsequence, say -1, -1, -1, -1. So I am taking x1, x3, x5 and so on. So this is a subsequence. Is it convergent? Yes, it is convergent to, this is convergent to -1. I can also take a subsequence 1, 1, 1, 1, and this is convergent to 1. So you see the first sequence converges to -1, the second sequence converges to +1. So if you have two different convergent subsequences, both of them need not go to the same limit. If all the convergent subsequences go to the same limit, then the whole sequence itself is convergent, and the whole sequence itself is convergent. And remember, if a sequence is convergent, then every subsequence must go to the same limit. So these are some important points to keep in mind. There can be more than one, so more than one convergent subsequence of a bounded sequence. So this is something you have to keep in your mind. In fact, there can be infinite such sequences. We are not going to get into this infinite term too much. Okay, you can understand there can be more than one. If all possible, if all convergent subsequence go to the same limit, then the sequence itself is convergent. So, this is a very fundamental fact, and it will be good that when you look at Bolzano-Weierstrass theorem, you just keep in mind this fact. For example, you take this sequence which is also familiar. I am just trying to give you examples of easy sequences. We will give some harder sequences in exercises which you can try out, but they would not be so difficult. So, if you take this sequence, you take the subsequence say half, 1/4, 1/6, 1/8, 1/10 and so on. But where does this sequence go? This sequence is also subsequence is going to 0. So, whatever subsequence you choose from here, all of the subsequences are going to 0. So, the sequence must also go to 0. So, these are the lessons you have to keep in your mind about Bolzano-Weierstrass theorem. So, once that is in your mind that every bounded sequence must have a convergent subsequence, then that allows you to prove something very deeper. It proves a result which is at the very heart of sequence theory. It tells you the true behavior of sequence. It tells you that if a sequence is convergent, then it has a very peculiar behavior. The behavior is that no matter that after a few number of terms of the sequence, that is after a finite number of terms, no matter how large is your m and n, the distance between them will always lie in a 2 epsilon band. The distance would always be in a 2 within 2 epsilon from each other, that is the individual distance, the distance between them should be always less than some epsilon, some given epsilon. So, means they always cluster very close to each other and also cluster to the number L to which they are going. So, this sort of behavior was first found out by Cauchy. So, there is a whole term called the Cauchy sequence. So, what is a Cauchy sequence? A sequence is called a Cauchy sequence if given any epsilon greater than 0, no matter how small, there exists n naught element of n. This is very important to note, such that for all m n bigger than this n naught, we have mod of xm minus xn. It could be that your n is n naught plus 1 and your m is n naught plus 50 million, does not matter. The distance between them can always be made less than this epsilon once the n naught is given. Sorry, I had a mistake here. For all m n greater than epsilon, so you have to keep in mind this right up. There exists an n naught, means you are counting from x1, x2 dot 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 up to xn naught. So, for all m n greater than or equal to n naught, this is always holding. So, this is a very important property that these points are clustering very near each other and also along the line. So, this is something of very fundamental importance. So, why a Cauchy sequence is important in our studies? The reason is as follows. Every convergent sequence is Cauchy. Two, every Cauchy sequence is bounded. Three, very important result, extremely important, every Cauchy sequence is convergent. So, a real sequence is convergent if and only if it is Cauchy. Every Cauchy sequence is convergent. This is a very important result of mathematical analysis. For example, if I just look at it as a problem and I want to prove every convergent sequence is Cauchy, how do I do it? So, what you do is that, take a convergent sequence, let x of n go to L. Now, given, which means given epsilon greater than 0, there exists some n naught depending on epsilon, a natural number, such that for all q bigger than or equal to n naught, we have x q minus L to be strictly less than epsilon, or maybe to make it little better, maybe I will take epsilon by 2. So, if I have epsilon greater than 0, then I also have epsilon by 2 greater than 0, then for that epsilon by 2 greater than 0, there would exist some n naught such that this would happen. So, this is true. Now, consider, so I am trying to use the epsilon delta language to just solve a problem. Now, do not think it as some theorem or something, you are just trying to solve a problem in calculus. So, now let us take any m and n such that m and n are greater than n naught, such that m and n greater than n naught. Now, let us look at what would I have. So, the distance x m minus x n, I can now write this as x m minus L plus L minus x n. So, I am adding L and I am subtracting L. So, now by the standard fact about absolute values, that is absolute value of A plus B is absolute value of A plus absolute value of B. Even if you have forgotten, just I am writing for you for your reference on the side, that for any real number this is of course true. It is sometimes called the triangle inequality. So, this by applying of course this inequality, we have so what we have got before, that once I given an epsilon, I will consider epsilon by 2, and for any, and I will find an n naught such that for whatever q I take which is bigger than n naught, x q minus L would be strictly less than epsilon by 2, but I have taken m and n such that m and n is bigger than n naught. So, for this n naught, x of m, because this is one of the q's, is strictly less than epsilon by 2, and x of n is also strictly less than by epsilon by 2. So, finally, it will make me conclude that x m minus x n is strictly less than epsilon by 2 for all m and n which is bigger than n naught. So, hence you have showed that this sequence is a Cauchy sequence, which is of very fundamental importance. Now, I will try to give you a sketch of how would you prove the, or at least have an understanding of this fundamental result, that every Cauchy sequence is convergent. This is very important to understand. This tells you a very important criteria, that is, if you look at if you want to prove a sequence is convergent, what is your job? Just prove the sequence is Cauchy. When Cauchy was giving a lecture on this in Paris, he wasn't very well accepted by students. They found that it was a very big wastage of time, but later on I will tell you little stories when we will talk about infinite series, which also Cauchy had a major role, that how important these ideas were in actually in natural sciences, in physics, in mechanics actually. So what would you do if you want to talk about the sequence, how you want to prove that the Cauchy sequence converges? So here you will see the application of the Bolzano-Weierstrass theorem. Okay. So the sketch of the proof is this, I am just giving a sketch. So your first step is that you know that Xn is given to be a Cauchy sequence, Xn is Cauchy. So by our second result on Cauchy sequence, it implies that Xn is bounded. Xn is bounded, and Xn is bounded means it has a convergent subsequence. So by Bolzano-Weierstrass theorem, it has a convergent subsequence. You could possibly denote it by XNR. So let XNR be such a sequence, XNR be, or XNK if you want, be such a subsequence. So what happens? So take epsilon greater than 0, so that would imply epsilon by 2 is greater than 0, and hence corresponding to epsilon by 2 greater than 0, there would exist R element of n such that for all R bigger than R or equal to R, you would have XNR minus L, which is the limit of this subsequence. So this subsequence is convergent. So let us assume that this subsequence goes to some limit L. So this would be strictly less than epsilon by 2 for all R greater than equal to R. So now your next step is to make use of the, so next step is, which we will give the detailed proof when we do your exercises, it will be asked as an exercise proof. So I am giving you the steps of the exercise. So use the fact that Xn is Cauchy and compute mod Xn minus L, which you can write it as the following. Mod Xn minus L can be written as mod Xn minus mod Xn R plus, sorry, I am just writing it in a slightly in a step jumped manner, XNR minus L. Now this could be also made strictly less than epsilon by 2 by the definition of the fact that Xn is Cauchy, and this can be made less than strictly epsilon by 2 because I already know. But how will you make this strictly less than epsilon by 2 needs some argument. So so you can basically show that this whole thing is less than epsilon. So your exercise, which will be a part of your assignment, would be fill up the argument. Try it at home, and I am telling you, once you can argue this out, you will see you will have a piece of joy or a thrill passing down your spine. I always enjoy when I can actually give a proper reasoning in a mathematical problem. I think there is no joy, for me at least, much better than that. Thank you very much and have a nice evening.